Welcome back. Looking at lesson 11, uh, adding fractions. Adding fractions. Looking way back, if we were adding 1 over 11 plus 5 over 11 minus 4 over 11, we could also write that, since they all have the same denominator, we could also write that as 1 plus 5 minus 4 over 11. They all have the same denominator, so either of these ways would work. Just know that if you have the same denominator, you can then add what is in the numerator. So we'd work left to right and go 1 plus 5, 6, minus 4, 2. So that would be 2 over 11. We can also do the same thing with variables in the fractions. You start by finding the least common denominator and then once you do that, you are able to add what is in the numerator. So one more example, if we have b as the denominator in all of these, then we can add what is in the numerator. So we can write it like so: a plus 2 plus a plus 3 all over b. So I turned these three b's into 1, and I simply took the numerator and put it on top. So your answer here, what it would be simplified, is a plus a is 2a, 2 plus 3 is 5, all over b would be your answer. But the only reason you're able to solve is because it has the same denominator. So that's what we're going to work on in this first concept here with addition of fractions. So let's look at example 11.1. It says add all this. Well, right now we cannot add because this one has a denominator of 2a, ax squared, ax cubed. However, we can manipulate the equation by multiplying by the least common denominator. Now, the question is, okay, how do we find the least common denominator? It's not a number. Your least common denominator in these, it's basically a combination of everything on the bottom. So I would first look at your numbers. What's the biggest number? Well, 2 is the biggest number. So for my least common denominator, it's going to start with 2. What's next? A. Does any of the A's have more than 1? Nope. So A is the biggest part, and then X. Well, X cubed is the biggest, so therefore 2ax cubed would actually be my least common denominator. From here, what we are going to do is multiply each of these. I'm going to create a little more space here. Just remove 2ax cubed is our least common denominator. We're going to multiply all these by 2ax cubed over 2ax cubed. And what we're basically doing is multiplying by 1, because this divided by itself is 1. So you're always welcome and allowed to multiply by 1. So what we do is we cross out what we have in common here. 2a is already there, and 2a is already here. So those can cross out. So we multiply x cubed times k and get, let's erase this for now. Kx cubed over your denominator, least common denominator. So we got that one figured out. So now we move on to the next one. Let's move this plus sign. And there are easier ways to do it, or quicker ways to do it. If I know that all this one is missing is a 2, hopefully this makes sense. For the ax squared, if I compared these, this one is missing a 2, and it's missing an x. So it's missing a 2x. So really, all I need to do is multiply the top by 2x and just plug in the least common denominator. So I would plug in the 2x here, multiply that, so it'd be plus 2xbc over what we already know is going to be our least common denominator. So hopefully that made sense. You're finding what's missing and multiplying that in the numerator. And then just changing the denominator to, oh, that was a little far. Change the denominator to 2ax cubed. Do the same thing here. This one has ax cubed, so this one is only missing the 2. So therefore, all I need to do is plug in a 2 up here. So 2m over 2ax cubed. Now we have our common denominator, least common denominator, and we can add what is in the numerator. So kx cubed plus 2xbc minus 2m, all divided by 2ax cubed. Hey, there would be our answer. So it's long and slightly frustrating, but you get to the answer. Let's do one more example. Let's do example 11.2. And I'll try to do this one kind of the longer way rather than the quicker way to make sure we got it. We want to add m over k minus b plus cx over ak squared. Alright, so this is what we're doing. What is our least common denominator? Well, this one only has k, this one's denominator is 1, and this one has ak squared. So we can go ahead and know that ak squared is our least common denominator. So I'm going to write that on the bottom of all these. And what we're going to do is multiply by ak squared over ak squared. Alright, 1k crosses out there. So that turns this into m times ak over ak squared. We multiply this by ak squared over ak squared. Well, nothing would cross out, so you would just get bak squared over ak squared. This one, it already has the common denominator, so you actually don't even have to multiply at all. You can just leave it as cx. And now you just simplify m ak minus bak squared all over your denominator ak squared. There's your answer. So that's how you add fractions, get the common denominator. Next concept is inscribed angles and central angles. Central angles first are if we know that these are two radius, meaning they meet in the center of the circle, because clearly that's the center. If these are both radius, then this angle right here is going to be the same measurement as the degree of this arc. So if this is 44, we automatically know that is 44, and vice versa. An inscribed angle is where, say we know the measure of the arc being 44, inscribed angle is actually, okay, this is the inscribed angle, and it is actually half of the arc measure. Half of the arc measure. So therefore this angle, half of 44, would be 22. So I could have a bunch of inscribed angles here. I'm going to make it look a little funky. It could go here. Whoa, look at that. Well, if I isolated this, I'm going to make this one bold. Okay, and I'll get rid of that so you can see it. That's also 22 degrees. What about this one right here? Oh, kind of missed my line. Also 22 degrees, but you get the picture. Inscribed angle is half of the arc that it's intercepting. Let's look at one example problem. 11.3. Try to solve this. It says find x. gives us 5x for this part of the arc, 7x plus 40 for this part of the arc, and then it gives us 40 degrees. Well, what did we just talk about? We just talked about inscribed angles, so I'm going to assume we solved this with inscribed angles. This is an inscribed angle to its intercepting arc right here, the remaining part of the circle that we need to know. So if this is half of this arc, that means we just need to multiply it by 2 to figure out the arc, so multiply by 2, that's 80. 80. And then we know that there are 360 degrees in a circle, so 360 equals 80 plus 7x plus 40 plus 5x. And then you just solve. 80 and 40, 120. 7x, 5x. 12x. And moving along, subtract 120. 240 equals 12x. And when you divide that by 2, you get 20. So x would be 20. And that is how you solve those. And that is the end of lesson 11.